Hi everybody, thanks for coming. My name is Stephen Brooks. I was primarily responsible for the software design and programming. This is Sharon Choi, our team leader. She primarily worked on hardware selection and assembly. We have Mark Cordova. He also worked on hardware selection and assembly. Next to Mark, we have Manpreet Dot. She programmed our embedded devices. And next to Manpreet, we have Luis Hall Valdez, which worked on our speech programming proof of concepts. Our team name is RoboSense. Our project objective was to create a modular, transferable sensory solution for humanoid robots. The purpose of the project was to design that sensory solution to potentially help kids with autism learn social interactions. Some of the technologies that we used were the NVIDIA Jetson TX2, which is a hardware development platform for artificial intelligence. We also used the Robot operating system, which is a framework for managing large-scale robotic software. We also developed a Internet of Robotic Things module that runs on Amazon Web Services using a REST API that enables a remote user to gather sensor data or send commands to the robot in real time. Some of our accomplishments were that we programmed over 26 embedded devices to give us approximately 10 different specific interactions or behaviors. We spent about more than 1,600 hours developing the project and generated a code base of over 5,000 lines to hand off to the HPS lab here at UTD for further development and refinement. So that pretty much sums up our project, so I'd like to open it up for questions.
How were you able to measure the average response time?
So I actually just wrote a little bit of code just to take the measurement of time when an interaction begins, such as like a sensor detects some kind of voltage, like if we had a touch sensor, for example, to detect our pats on the back. That interaction may be that after it detects that touch, it says thank you. That's what we did develop for that interaction. So I log that time whenever the touch is registered, and then I log the time that the robot operating system recognizes that it needs to react to it. And so I just take the difference, and we did several different tests and took the average.
How is it supposed to help autistic kids?
So, you know, autistic children, they kind of suffer from having difficulty socializing, right?
They don't like to touch themselves, for sure.
Right. So there's other products out there that are kind of trying to do this kind of thing, but it's still sort of experimental. So I think that in our initial research, we found that this is one approach because children are less anxious.
This approach, what is your approach?
How would a kid use it?
Yeah, how would a kid?
The robot responds.
I'm sorry.
The robot responds to several different appropriate manners. For example, we have 3 IR sensors situated on the forehead so that the robot faces whoever it is interacting with at the moment. So that would teach an autistic child that it is appropriate for them to make eye contact and to accept certain pats on the back or hugs and respond to them appropriately. So.
Yeah, it better be pretty tough. Kids I know, but.
Yeah.
Nick,
Yes, sir.
I believe there was an extremely similar project a year ago sponsored by the same lab, so how are you different than what they did?
So last year they used a microcontroller. We're using the NVIDIA Jetson TX2 to enable integration with like the previous group that presented, and then
I was going to say, last year they were asked to put it on a vest, but they couldn't put it on a vest, so this year we actually were able to do that, and we made it modular where we have like basically Velcro on it so that like parts can be removed and reattached to other places. So
yeah, that was one big focus of the project. The professor wanted to make sure that this was a solution that we can transfer from one humanoid robot to another.
So this is kind of a continuation of
It's-
that, and you springboarded, or?
Yes.
Or did you
yes.
start
Well, we actually redeveloped the entire project from the beginning because we're using Robot Operating System, a brand new hardware platform.
All right, thank you.
Let's thank this team.